Okay, here's page 2. Hopefully recorded the right way up. So you might have had to turn your Chromebook or phone or whatever you're watching that on sideways last time, but this one should be okay. All right, this problem is going to be the same tomorrow. The only difference is that it is this number is going to be different. Okay, so if you listen to this, it's probably the most important video. It'd be pretty hard to get a 4 on the test without getting it mostly right. Mr. Thacker's making a playpen for his wiener dogs. He has 46 feet of fencing for the sides of the playpen. If the pin is rectangular, create a model for the area of the pin. Make sure you include a table, add more rows if needed, a graph, label the X and Y axis, and an equation for your area. Okay, so I need to come up with an equation here. If you're in second period, you could probably skip about a minute until when I'm going to start filling in this table, but you have dealt with like basic linear equations, okay? Like the example I just gave to second period was, this would be like going to the movies, paying $10, and then each popcorn you buy is $4. So I could use this equation to put in buckets of popcorn to see how much my trip to the movies is going to cost me. What I want here is I want one length of my rectangular fence, and I want to be able to plug that length into a formula and have it give me, this is Y, how much area I would have for my dogs. So, for example, if this was my pin, and I started with the number 1, and the perimeter is 46 feet, so it's 46 feet around, that would make this 22 and 22. So if my length is 1, my width is 22, and my perimeter is 46. It has to be. So this, every single time, is going to be 46. Tomorrow it'll be a new number. And its area is 1 times 22, which is 22. Now, what if I have a length of 2? So this formula I create is going to be able to handle decimals and fractions too, because in the real world it's not always going to come out nicely. So now I have 2 and 2, and then what would that make my other sides? Well, that'd be 21 and 21, because when I add all those up I get 46. So you're going to start to see a pattern here. Now my area is 2 times 21, which is 42. Now if I make this a 3, this is going to go up to a 3. This is the pattern, by the way. This is going to go up to a 3. And this is going to go down to a 20. And again, all those add to 46. Tomorrow they're going to add to something else. And 3 times 20 is 60. Okay, so I'm just going to continue this pattern. I don't need to draw the rectangle anymore because I see that there is a relationship in the table. And the relationship is going to be 4, 19, so up and then down, and then I have to do 4 times 19, which is 76, and 5 and 18, which is 90, and then 6 and 17 is going to be 102, and then 7 and 16, I'm going to use a calculator for. 7 times 16 is 112. Then I'm going to have 8 and 15, which I know is 120. And then this is where I have to add more rows. And you'll notice at this point in the problem, I'm starting to get repeats. So I don't have to use a calculator anymore. So when I go 14 and 9, all I have to do is look back here, because I did 9 and 14. And I'm just going to do one more. I lied, 2 more. And you'll see why in a minute. Okay, so there's the table. Now I need to do graph and equation. So for the graph, this is going to be length, and this is going to be area on the y-axis. So not length and width, okay? I want to know, okay, if my length is 1, my area is 22. Okay, my length is 2, 42. That's all I need to know. Okay, so I want to know if I come up with a certain length, I want a graph, I want an equation that's going to tell me what the area is that I'm going to have with this problem. So my x-axis is length, which is the numbers 1 through, well, what's the biggest one we're going to need? So picture this table going up. It would have gone to 18, 19, it would have gone to 20, and this would have gone 5, 4, 3, 2, 1. It's going to go up to 22. Okay, so what I want to do for the x-axis, I can actually count by ones. So make a mark every 5 blocks. Now the y-axis, it's going to need to go a lot bigger because I'm going from 22 to my biggest area of 132. So on that one, I'm going to count by 30s. Every 5 is going to be 30. So 30, 60, 90, 120, and 150. Because I need to be able to go up to 132. And now I have to plot my points, x, y. So the first one I'm going to plot is here, which remember is 122. So this is x and that's y. We're kind of ignoring the 2 numbers that are in the middle. So 1 over, and probably be about there. Okay, and then 2 over, and 42 up. It's going to be kind of in between there. And 360 is exact. Okay, there's 360. And then just keep going. As I do, you can do yours. And you can start to see there's a pattern. 590 should land exact. So if it lands exact, I should see it land exact. The other ones you can kind of eyeball. 8, 120. And then I don't even need to look on the way back down because it's going to mirror, right? And that's what these quadratic graphs do. They mirror on each side. Okay? And this gives me a very general idea of what the graph looks like. Okay, there you go. Now we need to do the equation. All right, so for the equation, it's just like the first page, but we're ignoring the things that are in the middle, okay? So again, this is x, and this is y, so ignore the width and the perimeter. Okay, so I'm gonna redraw this to make it clearer, because those numbers in the middle confuse me. X, y, 1, 22, 2, 42, 360, and 476. That's enough. I can get the equation from that. My first difference is 20, 18, and 16. My second difference is negative 2. Don't put positive 2. Okay, it's going down 2 the whole time for the second difference. So this is going to tell me that A, let me switch to color you can see better. A is half of the second difference. C is what's across from 0. Here's 0. This number must be 22. And 22 minus 22 is 0, which makes sense because if my length is 0, my area would be 0. And now I have to plug in 122. Running out of room here, but we can do it down here. So 22 is equal to, I have x as 1, and I have y set to 22, is equal to a, which is negative 1, times x squared, plus bx, plus c, and then b is going to be 23. So my equation is going to be y is equal to negative 1x squared plus 23x. And we hope that this works. Okay, I don't need that 1. I can just have negative x squared. So when I do this, when I plug in something like 3, I better get 60. I hope so. Three squared is 9. I'll explain that in a minute. Times 23 times 3. 23 times 3 is 69. Plus negative 9 is 60. It worked. Now, I'm probably going to get a question, why is that negative 9? Well, remember how we added 1 here? Okay, remember this is 1 times negative, or this is negative 1 times x squared. So x is 3 in that case, and 3 squared is 9, times negative 1 is negative 9. So that's going to make it a negative. Just to prove that it works, when I plug in 5, I ought to get 90. So 5 squared is 25, times negative 1 is negative 25, plus 23 times 5. And 23 times 5 is 115 minus 25 is 90. 90. And that is the big problem of the test.